Hello, it's Keith here, and this is lesson 57 of the platform-specific series of my 68000 assembly programming tutorials. We're looking at how to do interrupts today. We're looking at the NeoGeo. So what we're going to do is we're going to use the interrupt, and we're going to put the music, and we're going to time the music using the VBlank interrupt handler. Now, we have actually used VBlank before. We've used it as part of our main tutorials. We put a flag there that we used to detect when VBlank was occurring. But this time we're going to sort of go into it in a bit more depth and really sort of break down how the interrupt handler works and how we control it. So let's go over to our code and take a peek. Now, the example today is an extension of the Mintile example that we used before. Now, the Mintile example showed a tile map system. It was a software tile map on some systems, but it's multi-platform, works in the same way on all of them. We're not going to cover that today. There's a separate tutorial on how the graphics work. We're just keeping the graphics example there to prove that the sound is not negatively affecting the graphics or the input in any way. So all we're going to look at today is the sound and the interrupts. Now, the first thing we need to do when we will have interrupts on the NeoGeo is we need to put an interrupt in our interrupt vectors in the header of the cartridge. So here is the start of our cartridge here. We've got various addresses that do various things. Now, we have these interrupt levels here, and they go from 0 to 7. Now, the one we are interested in is interrupt 1, which is the VBlank interrupt at memory address 64. So the very start of the cartridge nearly, and we put the address of our interrupt handler, and there's a couple of others there as well. Now, these were all in the template that I used for this. This I didn't write the template, I've just modified it. It's taken from this example here. It's very, very big, so I've used their template because it's far better than I could write. But what I've done is I've sort of broken down the parts we're going to be looking at today. Now, we've defined our interrupt handler, and we'll take a peek at the actual contents of the source code in just a second, because we've not actually done just quite enough yet to get the interrupts to fire. Now, what we need to do is we need to set the interrupt level in the SR register. So this is the system register that defines things like the supervisor state, so that bit, that S bit there, that 2 there is the supervisor state, and the interrupt level. Now, the numbered interrupt level we set, any interrupts that have a higher value will also execute. So here we're setting the interrupt level to 0, and what this actually means is interrupts 0 and onwards will all fire. So VBlank, IRQ2, IRQ3, and all the unused ones will all fire. So that's how that register works, but we do need to set that up. We were actually setting it up before though, so it's nothing new, but it's just something I wanted to bring up because it is, of course, important. Interrupts. Now, the interrupt handler itself, our VBlank interrupt, this does a few things. Now, the first thing it's actually doing is it's checking bit 7 of this address here. Now, this is actually part of the operating system. Basically, the operating system has sort of 2 modes. One is the system mode, where the system is actually still doing its things, and the other is the game mode. Now, I suspect part of this is related to the fact that the NeoGeo is, of course, arcade hardware, so it might be doing arcade system things rather than actual gameplay things. So the first thing we're doing is we're testing bit 7 of this address here, and basically if this is a 1, then we're in game mode, and so in that case we're going to jump to this part here. If it's a 0 though, then the operating system wants to actually process, and so we're going to instead pass control to this address here, which is the system interrupt 1 function, which is the BIOS's VBlank call there. So that's going to do all of the BIOS's work there. Now, as I say, during the normal gameplay that won't be the case, and so we will be taking control. So this is my code here. The first thing I'm doing is backing up here all the registers, and I'm restoring them at the end here. Important to notice, we're returning with an RTE command, return from exception. That's what we use for interrupts, and that will also restore the flags. So that's what that does. Now, there's a couple of things we need to do to keep the operating system happy. Now, the most important one possibly is kicking the watchdog. If you don't know what that means, the watchdog, again, this is arcade hardware, and it was designed that if it crashed, it would automatically reset itself. Now, kicking the watchdog, as unkind as it sounds, is actually telling the underlying hardware, our game hasn't crashed, please don't reset us, because, as I say, designed to run in an arcade, and the arcade always wants to be making money, and crashed machines do not make too much money. So that's what that does, and all we do here is we just move a byte of any kind to that address there. Another thing we need to do is we need to actually clear the interrupt that has occurred. Now, this address here, 3C000C, does that, and there's basically 3 kinds of interrupt. There's IRQ3, horizontal blank, and VBlank. And so it's VBlank we want to clear, and that is bit 2 there. So we're just writing the value 4 there, which clears that bit. So that is clearing the interrupt that has just occurred. So we've kicked the watchdog, we've cleared the interrupt, and so there's just a couple of other things we're going to do. We're going to run a routine called System IO. This is a BIOS call for doing System IO, obviously. So we're doing that. That's something we want to do. And then there's one other thing that we might want to do. Basically, there is an operating system function called mess out. Now, I believe this is for showing system messages to the screen. I'm not really sure if we need to do that, but it seems like we probably should. It certainly doesn't do any harm, so we're doing that as well. The last thing we're doing is we're clearing the VBlank flag. Now, this is something I've used in a few of my programs as a simple way of detecting when a VBlank has occurred. So you can just check, you can just write a value to this and then just see if it has changed, because when the VBlank occurs, it will have done so. So that's what we've got there. So those are the operating system and other little tasks we want to do. The final one is updating the music. Now, the music being played today is made by my multi-platform tracker ChibiTracks, and all we need to do to update the music and the hardware underneath is run ChibiTracks play. That will update the music. That's what that does. And that's all that our interrupt handler here has to do. You can see there's a couple of the interrupt handlers being defined here for IRQ2 and IRQ3. These are kind of similar. They are also proverbially kicking the watchdog, as it's called. So that's what that is there. And you can see they are also clearing their respective interrupts with 3C000C there. That's doing bit 0, that's doing bit 1, and we did bit 2 here. So that's all there is to that. So, and that's all there is to the interrupts. Very straightforward. As I say, you kind of need to do interrupts to some extent anyway, which is why I used this massive template that was found online from this website here, NeoGeo Assembly Programming for Absolute Beginners by Freem. Very good, certainly worth a look at there. So as I say, that's how we do that. Now what we're going to look at now just quickly is my music player. I'm just going to quickly describe how you can use it if you choose to do so. So ChibiTracks is the player, ChibiTracker is the Windows software that makes the music, and Chibi Sound Pro is the platform specific driver. The way this works is the music files, the binary music files, which you can see one of here, this song 1 here is a binary music file. That file will play on any system, even Z80 and 6502 systems and 68000 systems. The same binary music file will play on all the systems because the multi-platform tracker is hardware independent, will work on any system. And Chibi Sound Pro is the platform-specific sound driver. So this will have a NeoGeo component that handles the underlying NeoGeo requirements. This is the music player and its shared modules there for calculating the in-between notes. And this is the binary music file. So that's what we need to include to play our music. Now there is a couple of other things we need to do. Firstly, ChibiTracker does need some memory. It needs 128 bytes on the Z80 and 6502, but that goes up to about 256 on the 68000 because the 68000 uses those 24-bit addresses, so more memory needed. So we're just defining some RAM there, and we're defining pointers to some of the variables that ChibiTracks uses that we may want to look at or work with. We generally don't need to though. So that's just defining the memory for the player to work. Now at the start of our program, we just do need to do some setup for ChibiTracker. Just a single time, we need to run Chibi Sound Pro init. This sets up the platform-specific sound driver, so that's everything ready to play. The next thing we need to do is we need to load the address of our song, called song 1, to the address song base, which is a pointer within the RAM of the music player. We then run start song. That will set up the music player with the contents of the current song. If you change the song, you just need to run that again. You don't need to run Chibi Sound Pro again. You could, but you shouldn't need to. And then here we're actually overriding the song speed. That changes the playback speed. If we disable this, then the song will actually play a little bit too fast, I think, on this system. The song was exported for a 50 Hz system. This is a 60 Hz system, so it will play a little bit too fast, I believe. So yeah, that does sound a little bit fast there. So yeah, as I say, you can tweak the song up speed at playback time, but that is entirely optional. It's just because my song was exported for a 50 Hz system, and really that's all there is to it. As I say, always, you can go to my website and download the source code and the build script. That's the source code for today's file. ChibiTracks is free and open source as well, the music software for Windows, so please go ahead and get that if that is interesting to you. And as I always say, while I don't think you probably can, you are welcome to try and use this in any of your own projects, even if they're commercial. That's what it's available for, but I'm not trying to pretend my tutorials contain the most amazing code in the world. They certainly don't, but as I say, you're welcome to use them in any way you can. Anyway, hope you've enjoyed what you've seen today. If you've liked what you've seen, please like and subscribe, because I'm coming back with some more advanced tutorials. This was the Mintile graphics system. I've got a more advanced one called MaxTile coming out, which does better functionality, does X and Y flip and things. Mintile was designed for very simple games, not really ones that use complex tile map effects and multiple sprites, but MaxTile is far more advanced, so please stick around for that. I've got some other things coming as well, of course. Anyway, hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.